Introduction to the concept. Let's embark on an exciting journey to the very edges of what is possible in our world. Imagine that you are presented with the opportunity to travel through space and time at speeds that were once only the stuff of dreams. You've probably heard of the speed of light, the fastest speed in our universe, which is about 186,282 miles per second. For centuries, this limit has been a boundary where reality and fantasy intertwine. But what does it mean to move at a speed close to this? First and foremost, it challenges our understanding of physics and the laws by which we live. Scientists and science fiction writers around the world are fascinated by this topic, because it is here that mysteries lie which could change our understanding of time, space, and existence itself. In this video, we will explore the unexpected and often paradoxical effects of traveling at such speeds. After all, this is not just an academic exercise, it could become reality thanks to the latest advances in science and technology. Theorists and engineers are already working today on ways to bring us closer to this threshold. Innovative projects and experiments in high-energy physics, space exploration, and quantum mechanics promise to make the journey to 99% of the speed of light not just a topic for discussion, but a possible reality for our future. Together, we will explore why such speeds lead to epoch-making discoveries and what prospects await us. Get ready to immerse yourself in a world where the line between the possible and the real is gradually fading, leading us to a new understanding of the universe and our place in it. This journey begins right now. Chapter 2. Time slows down. In your imagination, you race through the boundless expanse of space, but every moment stretches out, becoming an eternity. At speeds close to the speed of light, time seems to undergo a transformation that goes beyond our everyday understanding. This is a unique temporal illusion, a direct consequence of Albert Einstein's theory of relativity, according to which time is not absolute and fixed, but depends on speed and motion. Amazing! But for an observer on Earth, your journey might seem to last an eternity, while on board the ship, time slows down almost to a standstill. Imagine this. The minutes passing in your life turn into centuries for those who stayed behind at home. This difference in the perception of time is called time dilation. This phenomenon acts as a kind of bridge between our known scientific laws and the unexplored mysteries of the universe. Let's dive into the details. If the ship were to reach 99% of the speed of light, the clocks on board would start ticking significantly slower than those on Earth. This means that for you, a 3-week journey could turn into many years back on your home planet. This is not just a theory, but a proven fact, confirmed by numerous experiments, including observations of elementary particles moving at high speeds. This concept may seem fantastic, but it is supported in practice. At such speeds, the past and future intertwine, and every moment reveals to us the full complexity of relativity. Get ready. This is only the beginning of our journey into a world where time becomes a seventh sense, mesmerizing with its mystery and opening up new horizons of understanding. Chapter 3. Space Contraction. The magnificent cosmos stretches out before you, and everything seems normal until you begin to accelerate to a phenomenal 99% of the speed of light. At this moment, the space familiar to us undergoes astonishing changes. It begins to contract. This striking phenomenon is known as Lorentz contraction. Imagine how your surroundings change dramatically. Galaxies that always seemed out of reach begin to draw closer before your very eyes. Planets appear stretched out and approach faster than you could ever have imagined. If you were on a spaceship, watching through the window, the sizes of objects around you would gradually shrink in the direction of travel. It seems like magic. However, this is pure science, demonstrating the brilliant theory of relativistic physics. This transformation could actually affect anyone who dared to embark on such a journey. The length of the spaceship and its equipment would decrease significantly in the direction of travel and the disciplinary cabin, and the ship's compartments would be compressed. Expeditions to distant planets would become noticeably shorter thanks to this unusual contraction of space. Distances that were once measured in millions of miles would now appear as incredibly manageable stretches. This remarkable effect of Lorentz contraction is not just an academic hypothesis. It is a real phenomenon observed in particle accelerators, where microscopic particles are accelerated to speeds close to the speed of light. Changes in the size of these particles could mean revolutionary possibilities for our space travel. Delving into this part of the theory of relativity reveals to us the fascination of invisible forces acting on a macroscopic level. These discoveries are changing our understanding of size and distance. Instead of the constant, reliable measurements of our everyday world, we see their transformations under conditions of such incredible motion. Our journey is rapidly turning into an exploration of the laws that raise the question of just how astonishing and unpredictable real space travel would be if we dared to set out at 99% the speed of light. But wait, we still have so much ahead of us to explore before we can answer that question definitively. Chapter 4. Mass Increase. Imagine your spaceship racing through the vast expanses of the universe, reaching unheard of speeds. However, as you accelerate to a phenomenal 99% of the speed of light, your ship begins to experience a remarkable phenomenon increase in mass. What seems unbelievable becomes reality in the world of high speeds, as described by Albert Einstein's special theory of relativity. So where does this extra mass come from? The fact is, as you approach the speed of light, the energy that would normally be converted into speed instead begins to manifest as additional mass. According to Einstein's equation, E equals mc squared, mass and energy are interconnected, and every additional portion of energy invested in acceleration changes the object's mass. This effect is evident not only on the macroscopic level, but also at the level of elementary particles in accelerators such as the Large Hadron Collider. Here, particles are accelerated to speeds close to the speed of light, and a noticeable increase in their mass is observed, which requires incredible effort to control and manipulate their movement. What does this mean for a spacecraft and its crew? The increase in mass affects the entire structure and equipment of the ship. Life support systems require more energy to maintain normal functions, navigation becomes more complicated, and even simple movements inside the ship demand increasing effort. Moreover, engineers will have to take into account the increased stress on the ship's materials, for which such a rise in mass could become critical. This may require innovative approaches in design and material science so that the ship can withstand such extreme conditions. Understanding and accounting for the increase in mass is a crucial step towards successful journeys at speeds we could previously only dream of. By recognizing this effect, scientists and engineers gain the opportunity to create technology capable of withstanding and utilizing such speeds for the benefit of humanity. We are only beginning to grasp all the complexities and wonders that come with traveling at the edge of the speed of light. Get ready to discover new horizons in our interstellar adventure. Chapter 5: The Distortion of Light. Imagine yourself hurtling through the infinity of space, with everything around you transforming into a bizarre play of light and shadow. But this is not just an illusion. When you reach 99% of the speed of light, the very light passing through space begins to distort under the influence of your incredible speed. The main effect we observe is the Doppler shift. Astronomers are well acquainted with it. It's the same effect that causes the pitch of an approaching or receding ambulance siren to change. The same thing happens with light. When you rapidly approach an object, the light waves are compressed, and that object appears bluer. This is called a blue shift. If you are moving away from an object, the waves are stretched out, and it appears redder. This is called a red shift. Imagine that as you race through the galaxy, the entire view of the world around you changes. Stars that were white or yellow begin to take on a different hue depending on your direction and speed. This kind of visual shift changes not only the colors but also the shapes of the objects themselves, turning your journey into a spectacle that combines both science and art. But the effect of the Doppler shift is not just an interesting sight, it's also important to consider its practical aspects. For your ship's life support system, including navigation systems, adjusting the trajectory can become a problem, and calculation errors may threaten the safe completion of the mission. This also complicates communication with Earth. Signals sent to your cruising platform can be altered and distorted, requiring the use of complex decoding algorithms. These technological obstacles only highlight how challenging it is to explore space at such speeds. Understanding the distortion of light becomes a key to a successful journey at 99%, the speed of light. This not only opens up new possibilities in the field of space exploration, but also allows us to once again appreciate the beauty of the surrounding universe as we travel through it at the very edge of speeds known to the human mind. Undoubtedly, our adventures in the world of light and darkness are becoming ever more complex and thrilling. Prepare to dive into the unknown and continue uncovering the mysteries of the universe in the next stage of our cosmic journey. Chapter 6: Colossal Energy. Let your imagination carry you to a world where your task is to accelerate a spacecraft to 99% of the speed of light. But here's the question: how much energy will this grand endeavor require, and where can it be found? The energy requirements in this case are simply colossal. To accelerate an object to 99% of the speed of light, you would need an incredible amount of energy on a scale humanity has never achieved throughout its entire history. The energy expenditure increases exponentially as you approach this unattainable speed. A remarkable fact remains that this is partly due to Einstein's famous equation E equals mc squared. According to this equation, energy and mass are interchangeable. The closer you get to the speed of light, the more energy is required, and this leads us to the increase in mass that we already mentioned. In other words, the faster you move, the harder and more expensive it becomes to keep accelerating. Where can we find such amounts of energy? Modern nuclear reactors and solar panels don't even come close to meeting this requirement. However, there are proposals and projects that could bring us closer to this future. One of them is using antimatter as an energy source. It has the potential to be extremely efficient. When it annihilates, antimatter can release an enormous amount of energy. A couple of kilograms of antimatter could sustain the flight of an interstellar ship at incredible speeds. Another option is future technologies, such as space propulsion that uses external forces, for example, solar sails or laser engines that concentrate beams of light to accelerate the vessel. However, each of these methods comes with its own challenges, difficulties in collecting, storing, and safely using the energy. Scientific advances in energy management and space engineering play a key role in making these concepts a reality. The colossal amount of energy required to reach 99% of the speed of light remains another complex puzzle for those who dream of conquering space. This makes us seriously consider alternatives and innovative approaches. Traveling along the star roads and reaching distant galaxies could become a reality if we solve the energy challenge before us. It requires intellect, science, and perhaps a bit of inspiration. Let your mind take flight, because the solution might be closer than we think. Chapter 7, Closer to Reality. Modern Research. As soon as you mentally race through extraordinary spaces and physical phenomena that arise at 99% the speed of light, the question arises, how far has modern science advanced toward achieving this grand goal? Is it really possible to approach such unimaginable speeds? In today's world, university laboratories, space agencies, and innovative companies are becoming true strongholds of future technologies. One of the key aspects of research is the development of more powerful and efficient devices that allow particles and objects to be accelerated to high speeds. Powerful particle accelerators, such as the Large Hadron Collider, are already helping physicists study the effects we discussed earlier, albeit at the level of microparticles. Modern experiments using laser technologies are also opening up prospects for future light-based engines. Concepts such as laser sails are being considered as real candidates for interstellar travel. Microscopic satellites controlled by laser beams seemed like fantasy not so long ago, but today they are actively discussed in the scientific community. The development of antimatter engine prototypes is also becoming a promising area of research. The enormous energy they can release during annihilation makes them a potential means for achieving high speeds. Despite the complexity of production and safety concerns, some laboratories have already begun conducting experiments in this field. Space research, both on Earth and beyond, continues to generate new approaches for producing and managing energy. We are seeing advancements in the creation of lighter and stronger materials to withstand the physical stresses at such high speeds. Ongoing experiments with the use of superconductors and magnetic fields are already showing promising results in increasing the efficiency and safety of space environment. Meanwhile, projects by space agencies such as NASA and ESA are intensively exploring the possibilities of interstellar travel. Programs aimed at searching for new planetary systems and studying their habitability are driving the development of technologies that can get us there as quickly as possible. So, step by step, our theoretical journey to 99% of the speed of light is beginning to take shape in reality. Those mysterious effects that once seemed unattainable to us are now becoming the focus of intense scientific research and technological development. Despite all the challenges, doors are opening before us to a new era where interstellar travel will no longer be just a dream. Scientific and technological breakthroughs continue to bring us closer to this phenomenal vision. Let's keep moving forward, following the stars, and see how far we can go on this journey.